Hi, welcome to In 5 Minutes. Next is the self-bias circuit with RS unbypassed. What that implies is you are not having any capacitor in parallel with RS. Now what happens to the gain? The effect we can see in this problem with RS and without RS. It is N channel JFET. Source, gate and drain. Input is applied to gate and output is taken from drain, so it is common source. Now the question is to find the input impedance, output impedance AV once with the output resistance, once without the output resistance. That is ZO once with RO, once without RO, and the voltage gain once with RO and without considering the output resistance. Now if a problem comes based on this, it will be of this type: self-bias configuration, Q point is given, then IDSS VP is given, YOS to find small RO or RD you can say. If you are using right RD, it is fine. Determine GM, RD, ZI, ZO with and without effects of small RO and compare the results, and similarly for the voltage gain. Now our first step in this, since Q point is given, we need not do the DC analysis. Directly we can find the value of GM. How to find the value of GM? You know the formula. GMO for the problem, GMO twice IDSS by mod of VP. This will give you GMO as 2 into 8 milliampere divided by VP is 6 volts. This will give you 2.67, and from this you can find GM as GMO 1 minus VGS by VP. Everything is given in the question. Just substituting, you'll get GM as 1.51 and small RO is 1 upon YOS. That will give you 50 kilo ohms. So for this we have got the values of GM and RO. Now to begin with the AC equivalent circuit. What we do for AC equivalent circuit, we remove all the capacitors from the circuit. So these capacitors will go, and the modeling of the JFET. So this is the circuit without considering the output resistance, small RO. If CS is removed from the circuit, RS will be a part of the AC equivalent circuit. Now in this you can see RS is shown in the AC equivalent circuit. As you know, ZI input impedance, ZO output impedance, then input voltage, output voltage, everything is shown. Now we can find ZI. ZI is the input impedance. What is the input impedance seen from the input side? VGS is open circuited. So what you can say, the input resistance ZI written as RG, total input resistance seen from the input port. Now we need to find ZO. How we can find ZO? ZO is output voltage upon output current. For input voltage VI to be 0. Now what does input voltage 0 implies is you have RG. Now RG becomes redundant in this case and VI is 0. Now when I am applying KVL at the drain, I can write IO plus ID is equal to GM into VGS. Why? IO and ID flowing towards D and GM VGS is flowing away from the drain. So IO plus ID is GM into VGS, right? So VGS can be written as minus of IO plus ID into RS. I can write, because the voltage across RS is minus of VGS and current flowing through RS is nothing but the combination of IO and ID. So total current flowing is GM into VGS can be written as IO plus ID, because the current flowing through RS is GM into VGS. So instead of GM VGS, I can write IO plus ID into RS, which is nothing but minus GM into VGS into RS. Why negative sign? Because see the polarity of GM VGS, it is negative positive. Usually we have positive negative, so this negative sign comes in the picture.